Right, what numbers do we need to go over? Surely there has to be some challenging problem. Nine point four. Wait, let me get this.
What?
John? So what? 37.
39.
Are you just shouting out numbers? You cannot ask unless you actually tried it.
I was just kidding. I was preparing myself.
You're gonna get a good grade. Just kidding.
It's April Fool's pop.
47. That's it. 33. You're gonna wait till I walk away, then you're gonna add another one. All right, 33. That's the one I took out. I showed you guys yesterday. Remember the segment? If you have a circle, here's the center, and you have these two radii, and you draw this chord in, this region here is called the segment of the circle. Now they're telling you that the radius of the circle is 8. Now this problem is going to be on the test, you don't even have to ask. And that angle is 70 degrees. Find the area of the shaded region. So how did we do it yesterday? The area of the sector minus the triangle, right? So how do you find the area of a sector? What's the formula?
1/2 r squared theta.
R squared theta. Okay, the radius is 8, so 8 squared times the angle, but the angle has to be measured in radians. So since it's given in degrees, you gotta multiply by pi over 180 to change it to radians. Okay, so that's the area of the sector, and then now you gotta subtract the triangle. And what's the fastest way to find the area of a triangle if you know two sides and the included angle? We learned this yesterday. 1/2 AB sine C, right? So 1/2 AB times the sine of this angle, 70 degrees. Take out your calculator, blah, 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 and then finish. Okay, so this problem is going to be on the test. You don't even have to ask. The only difference is you have different radius and different angle. Okay, 37. Dimensions of whole plate. Are you kidding me? I think I'm going to put this one on the test. I might take off. I like this problem better, I think. Hey, this is the actual dimensions of home plate. This is like a real problem, it's not fake. So I'm assuming we're finding the area? Yeah, find the area in square inches. These are all given in inches. So how do we do that? Well, if you draw this line in, then you got a what? You got a rectangle and a triangle. So that's 17. So what's the area of the rectangle part? This part. Length times width, right? So 17 times 8.5. That's the area of the rectangle. Plus, how do you find the area of a triangle if you know three sides? Now, you can use Heron's formula if you want, but can you see you don't need to use Heron's formula? Because it's an isosceles triangle. If you have an isosceles triangle, when you draw in the height, it's going to be perpendicular. So doesn't that mean it's going to be 8.5 and 8.5? So to find the height there, you can just use Pythagorean theorem. So you don't need to use Heron's formula. However, if you want to use Heron's formula, you can. It will work. But I think Pythagorean theorem in the formula is a little easier. So if you know this and this, how do you find that? H squared is equal to 12 squared. This problem is not as good as I thought it was going to be. Okay, so I did something wrong. Look, it's h squared plus 8.5 squared equals 12 squared. So h squared is equal to 12 squared minus 8.5 squared. So h is equal to the square root of 12 squared minus 8.5 squared. And then you can punch that one in on your calculator. So the area of this triangle up here is simply 1/2 base times height. What's the base? 17. What's the height? That thing there. Square root of 12 squared minus 8.5 squared. And then punch it in your calculator. Well, how many of you use Heron's formula? And it worked, right? Of course, it's going to work on any triangle, but if you have a special right triangle like equilateral or isosceles, then you don't need to. Whatever. And then 47. There's 47. Perfect triangles. A perfect triangle is one having natural number sides for which the area is numerically equal to the perimeter. Oh, I didn't know that. I mean, I read it, but I didn't know that. So 9, 10, and 17. So they're saying that if you have a triangle with these sides, it's a perfect triangle. And what's a perfect triangle? If you read the book, John?
One that something like the sides are equal to the angle measurement of.
No, there's nothing with angle.
It's April
You better
Fools.
read your book, April Fools.
April Fools.
I'm going to give you credit for April Fools. Show that it says a perfect triangle is one having natural number sides. You guys know what natural numbers are. 1, 2, 3, 4, 5, and so forth. For which the area is numerically equal to the perimeter.
Oh.
So the area and the perimeter are the same number. Okay, so look at this. What is the perimeter of this? How do you find the perimeter of a triangle with sides 9, 10, and 17? You add them up and you get 36. So that means if I compute the area, it should also be 36. So they want you to show that it's going to come out to 36. So if these are the three sides of a triangle, how do I find the area? What do I do? Heron's formula. So what's the first thing you should compute when you use Heron's formula? The semi-perimeter. So that's 9 plus 10 plus 17 over 2, which is 36 over 2, 18. So using Heron's formula, the area is equal to the square root of s times s minus one side, s minus another side, and then s minus the third side. So hopefully, if I do everything correctly, this should come out to 36. So that comes out to square root of 18 times 9 times 8 times 1. Okay, do I really have to put the 1 there?
No.
Now, does that come out to 36?
Let's see.
No, you don't need a calculator for this. Look at that.
Let's not try.
No, you don't need a calculator.
Oh, I see.
Okay, watch this. Okay, if you want to use a calculator, yes. If you want to multiply it out, it comes out to root 1296, which is 36. But I'm going to show you. See. Look, watch this. Just factor isn't 18 9 times 2? So isn't 9 times 9, let's just put 9 squared. And then you got 2 times 8, which is 16, right? Isn't 16 4 squared? The 9 squared comes out of the radical as a 9, and the 4 squared comes out of the radical as a 4, and then you get 36. See, you don't need no stinking calculator. Whatever. Anyway, now you know what a perfect triangle is. The perimeter is the same as the area. It's neat. I thought that was neat, but apparently I was the only one.
Do you know any other triangles in school?
Yeah, 6, 25, 29.
Let's try that one.
It's in the book, that's how I know. But then you don't know because you don't need to read it. Oh boy. Alright, no other questions. See how easy last night's homework was? Okay, so tonight's homework, let's look at the website. You go on the website. So, fourth quarter stuff, I put all of this on. So here, practice test. Boom! Hey, that looks like today's quiz. The only difference of today's on the test though, you see this first one, you're going to have to work with degrees, minutes, and seconds. Just for one problem. I'm just going to do it for one problem. The others look easy. Second page, compute the areas of the triangles, just like last night's homework, so you got to use Heron's formula and the 1/2 AB sine C. And then now, I'm going to ask you to extend what you know. compute the area of the following quadrilateral. So how do you compute the area of a quadrilateral? You make two triangles. So now you have to decide, should I draw this line in or should I draw that line in? What's gonna make the problem easier? I'm not gonna tell you, you guys do it. So same thing with this. Should I draw that line or that line? And there you go. That's the segment problem right there, I told you. Okay, so that's definitely on the test. And then I got some more. Remember this, what the heck just happened? What happened? Ah! What the heck happened? I don't even know what's happening here. Anyway, so here's a word problem. Look, I drew the picture for you, so it's up in here. Okay, remember we did this the first day, find the area of a regular decagon?
Yes.
Okay, so you're gonna have this problem, except I'm just gonna change the number of sides, okay? And then the last problem, look, I give you a picture. Find the area of the shade. How would you find the area of the shaded region? What would you do?
You find it.
Find the area of the triangle, and then subtract the sector, right? And all of this is gonna be done on the calculator, so this test is gonna be pretty easy unless it's not. And then look, I have solutions for you. I
Hey.
got solutions, like it's on there, just like I normally do. Okay, we are done. I'm gonna give you this. Look, you got 30 minutes left. You can do some damage on this.
Sprout, I'm gonna go print it out.
You have an iPad.
Yeah, but my handwriting is way too messy on Nobility. Would anyone like a copy?
Okay, whatever, Danny. Yes. And who said they had to leave early? Somebody said they had to leave